Hello everyone, welcome to the Introduction to Mechanical and Industrial Engineering course, MIC 130. This is Dr. Muhammad Chat. I'll be your instructor for this course, Introduction to Mechanical and Industrial Engineering course. From the course title, it is Introduction to these two measures of engineering. What does it mean, measure of engineering? Very quick, measure of engineering, if we're going to talk about mechanical engineering, it is a measure. Industrial engineering, it is a measure. Civil engineering, electrical engineering, computer engineering, chemical engineering, all of these are different measures of a study of the engineering. Or you could say that these are different subjects or different sectors of engineering. And if you are acquiring a degree in any one of these measures, definitely you're going to graduate with a bachelor, whatever it is, bachelor in engineering or bachelor of science. And we're going to discuss the difference between these two degrees, like what is the difference between bachelor in mechanical engineering and a bachelor of science in mechanical engineering. So all of these things will be fixed and will be discussed through this course, definitely. In addition, this is like a more extensive information session about these two measures of study, mechanical engineering and industrial engineering. So what do you expect actually in this course? We are going to introduce to you these two measures. What are the provisions that we're going to discuss, the provision that you should acquire upon the graduation? Like if you have a Bachelor of Science in Mechanical Engineering, what you're going to do in the workforce after the graduation? You're going to be mechanical engineer, yes, but what are the fields of work? What are which are known as the provisions of mechanical engineering? This is one of the things that we are going to discuss as well, starting even this introduction lecture. So also in the meanwhile, we're going to give you some examples of the different subjects and courses that you are going to study. So for example, to have a Bachelor of Science in Mechanical Engineering or Industrial Engineering, what are the courses that you should study and succeed in order to have this bachelor? So this study plan and like the different subjects and courses that you should study for these two programs of mechanical or industrial engineering, this is also one of the things that we are going to discuss through this course. In the meanwhile, we're gonna give you some examples of the different topics, and we're gonna practice you handling some things which are related to the mechanical engineering and industrial engineering. Another thing that you should expect, that you're gonna have a project which related to either the mechanical engineering or industrial engineering as one of the requirements of this course. So you could say that through this course, we're gonna give you like an overview, what you are going to do over the next 4 years to have a Bachelor of Science in Mechanical Engineering. In addition, we're gonna give you some information about what you are going to do upon the graduation in the workforce as a mechanical engineer. This is also going to be one of the things that we are going to discuss through this course. So what we're going to do in this lecture, I'm just gonna give you like introduction about what does it mean engineering, what is the difference between engineering and science. We're gonna give like a little bit introduction about mechanical and industrial engineering, and mainly we are going to discuss the mechanical and industrial provisions. So what you are going to do upon the graduation, what are the different job titles. If you are a mechanical, if you do have a Bachelor of Science in Mechanical Engineering or Bachelor of Science in Industrial Engineering, these things will be discussed through these slides. This slides or this part one, which is introduction to mechanical. So this is the introduction of this course, right? So don't be confused. This is introduction to this course, which is named Introduction to Mechanical and Industrial Engineering. So these introduction slides will be covered over 2 videos. This is the first video, and there should be another video that I will continue discussing these things, these slides as introduction to this course. Make sense? So the first thing that we are going to discuss here is what is engineering. Since we are talking about mechanical engineering and industrial engineering, many of you definitely would have, some questions What does it mean engineering? Should I be an engineer in general? Here we are talking about engineering in general. It is not necessary to be industrial or mechanical engineer or civil engineer. What type of engineering is? Here we are talking about the engineering in general. So starting with the word itself, engineering. Engineering, it had been driven from the Latin root engineer. Engineer, this Latin word, this word means is to design or devise. So simply we can say that engineering, it means that is to design. Engineering means is to design or to devise. So what does it mean, the word design? Let us talk a little bit about the word design. Design here, it should have, you should consider two things when we discussing the design. Design is to come up with new thing. But you come up with new thing for a reason. Not just for that. Like for example, you're gonna create something new. You're gonna invent something new. So this is design. But the key idea that you come up with new thing for a reason, for a purpose, to do something. We would think of the word design in a different way. Like let us assume that we do have a problem and we would like to fix this problem. So to come up with a way of fixing this problem, to come up with a device, with a tool, with a method, with an approach to fix this problem, this is design. So the word design, it has two parts. There should be a problem and we're gonna come up with a new thing to fix this problem. So we should have the new thing plus the problem. New thing and a reason. We created, we designed this thing to fix this problem. So this is the reason, which is the problem, and this is the new thing. So this is the word design. It should work in two parts. Like we do something for a reason. Or as it's gonna be clear as we discuss, especially the mechanical design, we are creating something for prescribed performance or for prescribed reasons. Like we do have a problem, as I mentioned, and we would like to fix this problem. So this is the physical meaning of design. What does it mean, design? So the design generally is to create, is to come up with something new. Create whatever the thing that you are going to create. You would create a method. You would create a service. You would create a tool. You would create or invent new device, a new approach, invent a new method. All of these could be classified as things that would be designed. So this is designed, but for a reason. Like we design something to help people. We invent this device because we had a problem in this old version of this device. So we are coming with a new version that fixes this problem. So this is the physical meaning of design. The same thing applies to device. Device is just to convert any idea into something that we can use. Device is something that me and you as human beings can use. So this is the physical meaning, or what does it mean, the word engineer, which is the original of the Latin word engineer, which the origin of the engineering subject itself. Some people would think of engineering as it comes from the Latin word ingenious, which means genius. It means that many of people think of engineer that they are genius guys, and they should be, like, because the way the subject that you are going to study, actually it depends a lot on your brainstorming. So it is like a good practice to your brain. So that's why you are expected up on the graduation to be a smart guy at least. So it means that engineering is ingenious or genius. It means that you're gonna come up with innovative thing, with new thing. This is the what does it mean, engineering. So it is very interesting subject actually, and like a job title to be an engineer. So it is a good thing, in fact. So what are the things that you are expected, or what are the good things, or what you should have in terms of knowledge and skills to be a good engineer? Engineering is an application of knowledge of three things: mathematics, science, and materials. Like, for example, if you do have a brother, or if you do have, for example, some friends, even if you do have an engineer who already graduated, many of these students claim, why should we study mathematics, for example? We are engineers, right? So what is the benefit of mathematics in the engineering thing that we are using? Yes, it is very important. In order to be a good engineer, a qualified engineer, you should have some knowledge, not just some knowledge. You should have a good knowledge in mathematics, science, and materials, because the engineering is how to use this knowledge to come up with new things, how to use your knowledge of mathematics, science, and materials to design and devise. This is what does it mean engineering? Because there is a difference between engineering and science. Science, you study science for just knowing science. But engineering, we are studying science to use it to create something. So the concept is different. Here we are engineers, not scientists. There is a difference. So for example, if you are a scientist, it means that your study is just science. So you're gonna study mathematics to know about the mathematics, to be like a scientist, to be like a mathematician, like to create something new in the mathematics field. You would study science to be a scientist. You would study materials to be a material scientist, and so on. So the concept is different here. But engineering, it means that you should have knowledge in mathematics, some knowledge in science, knowledge in materials. And it is not just having knowledge, it's to know how you harness, how to use this knowledge to create and design and devise something. So you're gonna be engineer. So engineering is to know how to use this knowledge for application. This is the engineering. So engineers are equipped. So basically engineering is an application of the knowledge of mathematics, science, and materials to develop new and better technologies. We could use this knowledge to design new technologies, to design new devices, methods, approaches, services. All of these are classified as things to be designed. So this requires knowledge in mathematics, science, and material. Why these three subjects? Because simply mathematics, it's related to the mental and the brainstorming things. Like you should have ability to do some mathematical calculation. And science, you should have knowledge in physics, knowledge in other subjects which related to the engineering plus material, because you are as engineer, you're gonna create something, you're gonna invent something new. This something, it should be made of a material to bring it to a real part so we can use it, right? So you should have some knowledge about materials as well. So these are the main three subjects that you should have knowledge at to be a good engineer upon the graduation, right? And definitely, so that's why, for example, for any Bachelor of Mechanical Engineering or Bachelor, or for Mechanical Engineering, Civil Engineering, Electrical Engineering, Industrial Engineering, for any one of these majors, definitely there are some courses which are related to mathematics, some other courses related to science, some other courses which are related to the material. So upon the graduation, you're gonna skill yourself with a good knowledge in these three subjects. And in the meanwhile, you're gonna skill yourself how you can use them. You're gonna practice how you gonna use this knowledge to do engineering things for engineering application. This is the basic idea of engineering. Engineers are equipped with knowledge of mathematics, as I mentioned, science and materials, and the skills in communication and business. It is not just knowledge of these three subjects. In addition, you should have other skills. And this is the thing that you already going to practice. Whatever in Abu Dhabi University or any other university, it's gonna be the same way, the same approach. Like it is not just having knowledge in these three subjects or having knowledge in engineering, because you should have other skills, how you could convince people about your ideas. Because if you are going to design something new, you have to convince people about this thing. For example, so this requires some communication skills. You have to commercialize your design. It means that you should have some business skills. So in addition to your knowledge of mathematics, science, and material, you should have other skills. At least you should have some skills to communicate, to do some business, because business is related to the engineering for sure. Engineers apply the theories and principles of science and mathematics and materials. We can add materials to them to research and develop. This is also one of the things that engineer could do. Engineer could use mathematics, science, and materials to design something new, to create or to invent new technologies, devices, methods, and approaches. In the meanwhile, also they can use mathematics, science, and materials to research and develop. R&D, this is the commonly known as R&D division, right? This is the R&D division in any company. Like, for example, many of the industrial engineering companies, or what is the subject of the company itself, you're gonna find the department of R&D, which is research and development. It means that engineers also do have the capability to do some research and develop something new, because the engineering, as I mentioned, it is related mainly to design. So we already practicing, you as engineer is to create something new, is to come up with something new. It means that by definition, you should have some capabilities of research, of doing research and development, whatever, to fix some of the economical problems or to fix some technical problems. So we could create something which is related or is going to fix a problem related to economical things, as economical problem or technical problem. Technical problem here, what does it mean? The word technical, which is more related to the engineering thing. Like if we're gonna talk about a machine and this machine has a problem, so the problem within this machine, it will be classified as technical problem, as engineering problem, right? It makes sense. So as I said, there is to know how to use the theories and principles of science, mathematics, and material, and harness this knowledge to do research and development to fix a problem, whatever it is, economical problem or technical problem, or even using this knowledge to create something new. So R&D, which research and development, it means that you are going to create something new. Economical solutions, it means that there is a problem and you are going to fix this problem, whatever is economical problem or technical problem. Make sense? Engineers are capable of taking initiatives when handling work assignments. It means that you will be assigned some work, so you have to work independent. Like initiative work, taking initiatives, it means that you should work independent, have the capability to work by yourself. In many of the cases, especially if your experience is not big enough, in that case you would need some guide, but at certain limit of experience, you should have the capability to take your own decision and you're gonna work independent. Work independent, it means that you don't need a help. You can work and take decision on your assignment by yourself. Efficiently finding answers to problem. Again, our objective as engineer in general, like we do have a problem, how to fix it. This is engineering. How to fix it, to come up with things to fix it, this is design. And accepting additional responsibilities with success. So all of these are the qualifications of a good engineer. Engineers are able to communicate to a wide range of background. For example, you may as engineer communicate with a medical doctor. So you should have a little bit of it, especially if you decided to have a provision or a job title which related to medical things. Like for example, if we're gonna talk about the medical instrument, who's making the medical instrument? It should be engineer, right? So if you are engineer, who's gonna be responsible about this medical instrument, definitely should have some background about medical things, right? Because you're gonna create, you're gonna maintain, you're gonna work, you're gonna use these machines that do medical things, right? So you should have some background about the medical issues, right? So it means that you should have background, and engineers are able to communicate to a wide range of backgrounds and in all forms of verbal and written media. These are again some of the qualifications of a good engineer, right? So these are the things that you are experiencing. So again, simply we could do summary of this slide that engineering, it is driven from the Latin word engineer, which means design and device. Design, it means two things. Design, it means that you have a problem and you're gonna fix this problem. to come up with a new method, with a new approach, with a new technology, with a new device that would fix a problem. This problem would be economical problem or technical problem. How we can fix this problem, how we can do design in general or do device in general, this requires some knowledge in three main subjects: mathematics, science, and material. Engineers, they should have the skill. They should have the skills to harness their knowledge in mathematics, science, and material to create something new, to devise and to design, to use this knowledge in different engineering applications. This is what does it mean, engineering, right? Engineering is a very good subject, and it is the most popular major in almost nine of the three majors of industrial sectors. If we're going to talk about the industrial sectors, like for example, business services, this is a huge sector in industry. Business services, like it concerns with the business thing of the different companies, communication between the companies, fixing the business issues between the different companies. So this is also one of the sectors. There is a room for engineers in this sector of industry. Chemicals, which are the industrial sector that is responsible for developing chemical materials or all the chemicals, using them in different applications, the development of chemicals. So it requires also engineers, especially chemical engineers. So the engineering, it is a big sector there. Like communications, it requires engineer for sure. Electricity and gas, like electricity creation, like for example, the generation of electricity and gas. For example, the transportation of electricity, this requires engineer. This engineer, it is not necessary to be just electrical engineer. Definitely there is electrical engineer, there is civil engineer, there is mechanical engineer who work at electricity companies. The same thing for the gas, electronic components, industrial and commercial machinery, measuring instrument. Here, for example, for the measuring instrument, it is not necessary to be the instrument that would be used for engineering application, even the instrument that used for medical application. Like for example, to do any medical diagnosis, for sure you are using some XR, for example, device or an instrument. So these instruments are medical instruments, yes, but they have been developed by engineer, and they are monitored and maintained by engineer and controlled by engineers. So engineering is there in this measuring instrument. Oil and gas extraction, for sure this requires engineer. But in addition to engineering, require chemistry guys, require some other, like for example, for commercialization, require some other guys with some other backgrounds. It is not just engineering. So it is a huge sector that acquire or collect different fields and subjects together. One of them as a major definitely is engineering. Transportation, the transportation and transits in general, definitely they require engineers there. So engineering, it is everywhere. You could say that engineering is everywhere in our life. So engineering is a very interesting subject to study. Here, remember that here we are talking about engineering in general. This figure shows like a comparison in terms of between the different majors or the different specializations of engineering. So these are the engineering specializations or engineering majors of study. Specialization, it means that you are specialized as mechanical engineer or electrical engineer. So this basically up on the graduation. After you graduate, you're gonna be specialized in mechanical engineering or electrical engineering, depending on your experience. But if we are talking about the study, so these could be considered as majors or minors of studies. Some of these subjects could be considered as majors, like for example, mechanical engineering, it is a major. Civil engineering, it is a major. Industrial engineering, it is a major. Electrical and electronic, it is a major. Computer hardware, it is a major. Aerospace, major, and so on. These also could be considered majors. Some of them would be considered as minors. It depends on the university. It depends on the programs, the educational program that offered by this university. So it would be different from one university to the other. But definitely, if we're going to talk about civil, mechanical, industrial, and electrical engineering, these are majors. And some other universities, by the way, they would include industry as a minor or a track within the mechanical engineering. So that's why in this course we are discussing the mechanical and industrial engineering. Why? Because they kind of related. There are very common subjects and courses that both mechanical engineering and industrial engineering they are going to study. So that's why that is fine to discuss the mechanical and industrial in one subject, because as I said, they are related together. Half the way of the courses, half the courses almost of the mechanical and the industrial, they do having the same common courses, although the way of teaching the course would be a little bit different from mechanical to industrial, because depending on the background of the student, depending on the program itself. But anyway, the subjects are almost half the subjects are the same and common between mechanical and industrial engineering. So that's why some of the universities, they offer the industrial engineering as a minor of mechanical engineering or as a track of mechanical engineering. Like for example, you may have a mechanical engineering with a track in material science, with a track in manufacturing, with a track in industrial management or in industry, right? So these are different tracks, like different, like different concentrations kind of the mechanical engineering. So the industry would be included there. And if we did so, we definitely the percent of the mechanical and the industrial engineering will be increased. But anyway, this figure actually, or this map, this gives the percent of these specializations or these measures of engineering in the United States. And definitely this one would be, because it is kind of old, it is not updated. But anyway, this one would be different from one country to the other, but the difference will not be significant. It means that the percent will be a little bit shifted within the civil or the mechanical. But anyway, you're gonna find that the 3 or the 4 main measures of engineering are civil engineering, mechanical engineering, electrical engineering, and the industrial engineering. So these are the 4 big measures in any country, whatever it is. These are the measures of engineering. In the recent years, for sure, the computer science and computer hardware or computer engineering, it had been strongly added to this measure, but still we do have the civil, mechanical, and electrical engineering plus the industrial engineering are the main 4 measures of engineering that, for example, in the United States, 17.7% of the engineers in the United States are civil engineer. 15.2% of engineers in the United States are mechanical engineer. Industrial engineer, including health and safety, which related to the public health and safety issues, or engineering, the total is going to be 15.3, and electronic and electrical and electronics are 19.2% as measured. This is in the United States. As I said, it would these percent would change somehow, but a little bit from one country to the other, right? So again, mechanical engineering are measures of the engineering. And again, as I mentioned before, a major, it means that you should have a bachelor in mechanical engineering or bachelor of science in mechanical engineering and industrial engineering. It means that you're gonna acquire a bachelor degree to have such a major. So this is very quick. What does it mean, engineers? But what you should do, or what you are going to do if you do have a bachelor in engineering or a bachelor of science in one of these measures of the engineering. So what do engineers do exactly? Engineers do lots of things. When you graduate, you're gonna do 1 or 2 of these lots of things. So engineers can do so many things, like engineers can design. So remember, what does it mean, the word design? Design, it means that we don't have a problem and we need to fix it. So we're gonna come up with idea, service, approach, method, device, tool, thing to fix this problem. This is design. So engineer can design anything, which like products. Products is something that me and you are using as human beings. We are the users of this product. This product would be something that would be eaten, would be something that could be used, like this pen, for example. So these are products. So product is something that is useful that we can use, me and you can use. So engineer can produce these products. Here, remember that we are talking about engineers in general. It is not necessary to be mechanical or industrial or civil engineer. For example, if we're gonna talk about civil engineer, what is his product? He's gonna design a product. For sure, his product is gonna be a building, a bridge, right? Which something that we're gonna use as human being. So the product that a civil engineer can do is a building, a bridge. What is the product that a mechanical engineer can do? It could be a product like this mug, like this bin. This is mechanical engineering. How we can produce this bin? This is mechanical engineering. Require manufacturing knowledge. We're gonna manufacture this product for a user, right? We could, the product would be your vehicle, your car that you are using every day to the school. The same, it would be machine, it would be anything. Machinery to build those products. It is not just providing a product. The engineer is not designing a product. He also could design the machinery or the tool that would be used for making this product. So you could be a mechanical design, or you could be an engineering designer, like you're gonna be designer who's designing the product, like doing the design of the vehicle. Then there should be other engineers who do invent the machinery and the methods of producing this product. So we have a product, we should find a way of building or producing this product. Plants, factories in which these products are made, like to the place in which that you're gonna make this product. This is also one of the responsibilities as design of engineers. Systems that ensure the quality of the product. Even it is not just making the product, it is making sure that you do have a good product as well. This is one of the engineering concerns, one of the concerns of the engineering design, and the efficiency of the workforce and manufacturing process. Make sure that all the technicians, all the operators, the workforce is working good, in a good shape. Everything is safety, in terms of safety, health, everything that would be related to making and ensuring the quality, a good quality and efficiency of making this product. This is also some of the concerns of the engineers as design. This could be classified as design. So design, again, that we do have a problem and we would like to fix it. It means that to come up with new product, new method, a machinery to build the product, plant or factory build this in which this product is going to be made, the system that ensures the quality of the product. All of this are related to the engineering things. Also, engineers can design, plan, and supervise. Like, for example, if we're gonna talk, this is just an example, the construction of buildings, highways, and transit system. So, for example, they can design, plan, and supervise the transit system, the highways, the buildings, all of this, also some of the responsibilities of engineers. So these are the things that you should expect upon the graduation as engineer. Engineers can design, develop, and implement ways to extract, process, and use raw materials such as the petroleum and natural gas. Like, for example, how you extract natural gas and petroleum material, how you can use them, how you can process. What does it mean, process? It means that how you can change in this material and to bring this material into another form so me and you can use. Like, it could be in the form of a product. Like, for example, the gas that you fill into your car, it is extracted, right? But we are not using this gas exactly the same way as it had been extracted from the ground, right? We should do some processing, some changes to this gas so we can use it. We can put it in our cars. This is the key idea of what does it mean, the word process. So it means engineer, they can extract, bring the raw material, process this raw material, change this raw material, and find a way to use it. So three things. First thing is to extract this material. Second issue is to process this material, bring this material into a shape that is beneficial, that we can use. Then find a way to use this material in different application to help human being. Engineers develop new material. Even engineers, they can develop new materials. We can invent new materials like artificial material. We can make these materials these days that both improve the performance of some products, of existing products, and take the advantage of advances in technologies. Like we are developing and inventing new technologies, and this is also one of the responsibilities of engineers, how we can make use of these technologies to create and invent new materials that would improve the performance of some of the existing products that we already everyday use. This definitely is some of the responsibilities of engineer. A pretty good example of this case is your cell phone, like the camera in your cell phone, like the pixel of your camera. If you remember, if you used to use a cell phone like 20 years ago, and if you just look to the quality of the camera at the 20 years ago, it was very bad quality, right? But at that time it was like invention, right? It was like new thing. So we do have cameras in our cell phone, but the quality of this camera, the pictures that we get through these cameras are very bad qualities, right? But over years, till the instant that we have now, we do have a very like high definition cameras and ultra high definition cameras that we can get very excellent pics using the camera of our cell phone. So we already coming with new material, with new inventions, with new technologies, with new things that we implement in our cell phone to enhance the quality of the pics that we can get through the cell phone camera, right? So to come up with these new technologies, this is design, this is development, this is one of the responsibilities of engineer, definitely for sure engineer who did this. Also engineer, they can harness it. It means that make use of something, like you do have something in head, use it. This is harnessing. The power of sun, that we do have sun, right? So it is a very good power source. Now there is a very good track of research and engineering which related to the how we can extract power from sun, from the earth, atoms, electricity for use in supply, even the electricity, which just the movement, this invention, which is the movement of electrons. So the movement, how we can harness the energy that comes from the movement of electrons to in a form which is the electricity that we currently use. It is a very big invention which definitely related to the engineering. Atoms, the movement of things inside the atom, the movement of the atom itself, it is also things or some of the concerns, and it has some energy, and there is development and research on this part to harness the energy inside the atom itself for using supply of the nation's power need and create millions of products using power. So this subject actually is related to the power engineering. This is some of the concerns of the power engineering. Power engineering, it would be mechanical power engineering, it would be chemical power engineering, it could be electrical power engineering. So what does it mean? For example, there is a track of or like a minor in mechanical engineering, which is known as mechanical power engineering. Mechanical power engineering, it means that is to use mechanical method to create power or to generate power, whatever from the sun, or using other like by burning fuel. For example, like for example, the heat combustion engines that used in our vehicles. This is also the concern of the power engineering as a mechanical engineering as a track in the mechanical engineering. Also, we may have electrical power engineering. Electrical power engineering, it means that their interest actually is to find a way to create electricity, to generate electricity, to transport the electricity. So this is also some of the concerns of the engineers. Engineers do analysis or analyze things. Like for example, do analysis, they should have skills to do analysis for the impact of the product that they develop or the system that they design on the environment and on people. Like we should have into account the impact of the things that we are doing as engineer on people and environment. For example, is it going to badly impact or affect the environment or not? If it is bad thing, we have to avoid it. We have to come up with another thing. The same thing, what is the effect of this technology on people, right? So these things should be considered or taken into account when we design, when we create something new for as one of the things that we should do as engineer. So simply, these are the different things that engineers should do. So far we discussed what does it mean engineering, the different measures of engineering, what are the different things that engineering usually do. Make sense? Now let us move to the difference between engineers and scientists. We have discussed before that engineering, it is the capability of using, is to design and devise. And in order to design and devise, you should have knowledge in mathematics, science, and materials, and know how you can use them for and implement or harness this knowledge to do something, to design and devise for different applications, right? So now the question is, what is the difference between engineer and scientist? This is another thing that you should understand. Unfortunately, so many engineers even who graduated, they don't recognize the difference between engineer and scientist. There is a difference that should be known. And if you acknowledge this difference, it's going to help you a lot through your study for the engineering, because you should know exactly what you should do as engineer, right? So a scientist first, he develops theories. Any new theories, it should be developed by a scientist. Any physical law, like for example, like Coulomb's law, like for example, the gravitational law and Newton's law, all of these are developed by scientists, right? And discover new phenomena. If you, the one who is responsible for finding and describing and putting a theory and description for any new phenomena, this is the responsibility of a scientist. But what is the thing that engineer gonna do? The engineer, he should use these theories, these physical laws, and the discovered phenomena by a scientist. He should know how he should understand them first. First, he should understand these theories, but he will not develop these theories. The scientist developed the theory, developed the physical law, discovered the phenomena. So the engineer should understand, should study these theories, physical laws, and these phenomena. Then he should find a way to design it. He should know how he can use these theories to design or invent new methods, technologies that would solve real world problems. So again, we design for a reason. We design or invent methods, technologies, approaches, services, whatever the thing that we are going to design, it should be designed to solve something. We do have a problem that we have to fix it. So to fix or solve real world problem, this is engineering. So we are not inventing new theories. We are not developing new theories or physical laws as engineers, but we understand the existing theories and physical laws and phenomena, and we know exactly how we can use them to design and invent, to fix a problem. This is the engineering. So this is the difference between a scientist and engineer. A scientist has an interest in basic science, while engineer is interested more on the applied science. So what is the difference between basic science and applied science? Basic science, this is the interest of the scientist, but the engineer, he is more interested in the applied science. What is the difference? Basic science, for example, like physics, mathematics, biology, these fundamental sciences, these fundamental fields of science, they are the source of most of the scientific theory that we today are using. So scientists, they should have strong knowledge in physics and mathematics and biology. And they know exactly how they can develop these theories and these mathematical concepts and these biological phenomena. They can discover them and they describe them. This is the basic science in the field or in the basic science. But the applied science, on the other hand, is using scientific discoveries to solve practical problems. So the applied science, it is more related to the application. We do have science, we do have basic science, how we can make use of this basic science in different applications. This is the applied science. So you should know the difference between these two different categories. So the concern of a scientist, again, is basic science, but the engineer is interested more in the applied science. So that's why in your study program for whatever mechanical engineering or industrial engineering or civil engineering, the study program of engineering should include both, especially in the first years. You're gonna study more something which is related to the basic science, that you're gonna study mathematics, you're gonna study physics. Definitely you aren't gonna study biology unless your major is biomechanics, for example, or something related to biomaterials, for example. So in that case, you should have some background on biology, so you're gonna study biology as well. But I'm talking about physics and mathematics in the majority of the engineering program. Definitely you're gonna have some courses related to physics and other courses related to mathematics. Someone would say, why should I study mathematics and physics? These basic sciences or these basic fields, you should scale yourself with this knowledge in physics and mathematics. You could able to understand the applied science. The applied science, which is the science that is related to your major, like mechanical engineering. Definitely you're gonna take a course like mechanical design. So in order to be able to understand the mechanical design, you should have knowledge first in physics and mathematics. So that's why the study of engineering is very interesting, because of that reason. Why? Because you're gonna take some courses which related more to the basic science. Then you're gonna, in the meanwhile, you're gonna take some other courses which are related to the applied science. Make sense? Engineering is applied science, but again, this doesn't mean that your study only is gonna be applied science. No. Your study is going to be hybrid between basic science and applied science. Courses related to physics, mathematics, and other courses which are related to your major, whatever it is, industrial engineering or mechanical engineering or the electrical engineering or civil engineering. As I'm going to show you for the mechanical and industrial engineering, what will be the basic science courses, and I'm going to show you what will be the applied science courses which are related to your major. Now, the last thing that I'm going to discuss through this video is the difference between the BSc, which stands for the Bachelor of Science. SC stands for Bachelor of Science in Engineering, whatever, like Bachelor of Science in Mechanical Engineering, Bachelor of Science in Industrial Engineering, Bachelor of Science in Civil Engineering, and so on, versus the Bachelor of Engineering, like Bachelor of Industrial Engineering, Bachelor of Mechanical Engineering. So there is no difference between the two terms. This is one term and this is another term. The difference between the two terms is the word science. Here there is science, there is no science. So what is the difference between these two degrees? These both are two different, not big different, Bachelor of degrees in engineering. Like this is, as I mentioned, Bachelor of Science, but this is Bachelor of Engineering. So 95% of colleges of engineering in the world, they offer Bachelor of Science in Engineering. Bachelor of Science in Engineering, like Abu Dhabi University, Khalifa University, any university in the UAE, many of the universities in the UAE except few of them. Even in the world, 95% of the colleges of engineering in the world, they do offer Bachelor of Science in Mechanical Engineering, Bachelor of Science in Industrial Engineering in general. A few colleges, however, offer Bachelors of Engineering, Bachelors of Engineering, a Bachelor of Engineering of Science in Engineering. So what is the difference between these two degrees? Because you should understand the difference here. Here in Abu Dhabi University, we are offering Bachelor of Science in Engineering, Bachelor of Science, not just Bachelor of Engineering, right? Whatever it is, Bachelor of Science in Mechanical Engineering or Bachelor of Science in Industrial Engineering. So a Bachelor of Science in Engineering focuses more on the cross-disciplinary application of science and mathematics and materials, for sure, on structures, machines, systems, and processes. It is more general. You could say that the Bachelor of Science, it is more general than the Bachelor of Engineering. So what does it mean? It means that, as I said, to have a degree as a Bachelor of Science in Engineering, you should study some courses which are related to the basic science like science, mathematics, materials, and so on. So you're going to study these basic sciences first. Then what? In the meanwhile, you're going to study some other applied sciences courses. Applied sciences courses like courses which are related to the mechanical engineering, or related to your major, whatever it is, mechanical or industrial engineering. So these are the courses, the applied sciences courses, that is gonna skill you or practice you how you can use this basic science for different engineering application, to design for structures application, for machines, for system processing like manufacturing, and so on. So this is the Bachelor of Science in Engineering, so it is more general. This type of engineering, I'm talking about the Bachelor of Science in Engineering, prepares students to enter the workforce as provisional engineer. You're gonna be engineer, and you will be qualified to work in to acquire any job title as engineer depending on your major. Like for example, if you do have a Bachelor of Science in Mechanical Engineering, your degree qualify you to be a mechanical engineer who could acquire any job title related to the mechanical engineering, whatever it is. You can work in any field. You are qualified to work in any field that is related to the mechanical engineering, whatever it is, as long as you do have a Bachelor of Science in Mechanical Engineering. So you are qualified to be a provisional engineer with the skills that are applicable to a wide variety of industries that you can work in any field. You can acquire any job title which is related to your major. A Bachelor of Science in Engineering degree often includes more advanced levels of applied science and mathematics than are taught in the Bachelor of Engineering degree. Like it is more advanced level. You could say that the Bachelor of Science, it is more advanced study that depend on the theory in addition to the application of these theories, that depend on the basic science in addition to the applied science. You study the theory, understand the theory, then you're gonna use this theory for different application. This is the Bachelor of Science in Engineering. But bachelors in engineering, you're gonna be more career oriented. You aren't gonna go deeply through the theories. You will not go deeply through the basic science, but you're gonna focus more on the applied science. This is the difference. So there is a very slight difference between the two bachelors, between the two programs, whatever it is, Bachelor of Science or Bachelors of Engineering. Make sense? So a Bachelor of Engineering is an engineering technology degree. It is more to be qualified or considered as technology degree, engineering technology, not engineering degree. There is also a difference between engineering technology degree. So you're gonna be like a technologist in that case, like the Higher College of Technology, for example. It is more technological things, like it is more career oriented. It depends more on the application side, more than the theoretical and the understanding and to know how you can use these theories so you can, after that, use them for different application. So, Bachelor of Engineering, it is more to be engineering technology degree, which is usually offered by an engineering technology program. Like, as I mentioned, the Higher College of Technology, like any technical school, so they could offer also as engineering technology. An engineering technology degree emphasizes the application. It focuses more on the application of a specific engineering technique. It depends on technical things. It will not guide you through the theory behind this technology, but it's gonna practice you more on using the technology. You got my point? So Bachelor of Science is gonna start from the theory. That is gonna explain to you the concept. It's gonna explain to you the theory. Then it's gonna practice you and show you and teach you how you can use this theory and concept for different engineering application. But so you could, if you have a Bachelor of Science in Engineering, you could develop and design something new which is related to the engineering. So that's why the Bachelor of Science of Engineering qualify you more to acquire a position as R&D, which is research and development, because you do have the capability, you do have the knowledge to develop something new, to do some research which is related to the engineering. But the Bachelor of Engineering, it is different. It go very quick over the theory. It won't gonna go deeply through the theories. Even it won't gonna explain the theories with more detail. It's just gonna show you the theory very quick, but it's gonna focus more on the technology that depend on that theory and practice you using this technology. So this is the difference between Bachelor of Engineering and Bachelor of Science Engineering. Bachelor of Science Engineering, this is the common, and it is more general. It qualifies you to work and acquire any job title related to the mechanical engineering or industrial engineering, as long as you have a Bachelor of Science. But if you do have a Bachelor's of Engineering, you can acquire job titles which are related to your major, specified to your knowledge, specified to the thing that you practiced while you acquire the Bachelor of Engineering. Some people would acquire or get both degrees, like Bachelor of Science and Bachelor of Engineering. So he gonna get the Bachelor of Science, then he gonna skill himself. He's gonna focus on a specific subject with more deep on the application on the technology side. So in that case, he gonna get a Bachelor of Engineering after he already got the Bachelor of Science in Engineering, right? Graduates with an engineering technology degree often seek employment in fields such as production, design, manufacturing, and operation, which almost the same thing, but the same thing for Bachelor of Science. So they're gonna be more, they can acquire position in any one of these sectors. The degrees of engineering technology, like Bachelor of Engineering and Bachelor of Science, like of Engineering, contain some development, but they are important characteristics that make them unique. Like as I said, we may teach the same courses in both programs, in both bachelors. We may teach the two programs, the same courses, like mechanical design and mechanical design there in the two bachelors, but the way of teaching the course is gonna be different. The labs that will be used, it's going to be different, because there we are focusing more on the technology in the Bachelor of Engineering, but here we are mixing the theory with the technology, right? So this is the difference. Students who obtain a Bachelor of Science in Engineering begin their career as entry-level engineer. They do have like zero experience, right? But they do qualify. They are qualified to acquire any job title related to their major, whatever it is. Then after they acquire this position as mechanical engineer, they're gonna get more experience as they keep working on the same subject of the mechanical, because mechanical engineering, for example, the same thing for industrial engineering, the same thing for civil engineering, it has lots of sectors, it has lots of fields that you can work on after the graduation. So which field exactly that you're gonna acquire after the graduation, we don't know. But your Bachelor of Science degree qualify you to acquire any position related to the mechanical engineering, whatever it is. Then once you get this position in a specific field, you're gonna gain more experience. You got my point? They typically do not have extensive experience in the field upon the graduation, but are very knowledgeable about cross-disciplinary application and process, and they are qualified to gain knowledge. They are qualified to learn more, right? Because their way of teaching engineering in the Bachelor of Science in Engineering depended on that issue, that we give the theory and we teach you how you can use the theory independently by yourself to do some engineering thing, to create and invent new things. This is the Bachelor of Science in Engineering. Graduates with an engineering technology degree are often called technologists. So if you already having Bachelor of Engineering, you are more being as technologist, more being than engineer. So why? Because you are depending more on the technology and and you know exactly how you can use this technology. So a Bachelor of Science in Engineering, he has more experience on this specific technology, but he has almost zero experience on the other things. Very weak experience on the other things in comparison to the Bachelor of Science in Engineering, where students who complete 2 years engineering technology, they are called technicians. So for example, some schools, they offer engineering technology program over 4 years, and some other they offer for over 2 years. If you're gonna get the engineering technology degree after 2 years, so you're gonna be a technician who knows exactly he can use this machine or tool or whatever. So he's a technician, he's not an engineer. But if you're already acquiring or having Bachelor of Engineering over 4 years. So you're gonna be engineer, yes, but more being as technologist more than being engineer, right? So engineering, it is a general idea. Engineering, especially Bachelor of Science in Engineering, you study theories, concepts, basic science, and you practice how you can use this basic science for different applied science and which are related to your major. So this is gonna give you a degree that is more general than even the Bachelor of Engineering. So that's why, as I mentioned, 95% of the universities in the world, they offer for engineering program, they offer Bachelor of Science. A few of them, they do offer the engineering technology degree, like Bachelor of Engineering. Like if we're gonna consider the UE as an example, I think the only school that offer engineering technology degrees is the Higher College of Technology. They offer Bachelor of Engineering, unless I'm wrong, but because it is Higher College of Technology, so it is even their engineering, mechanical engineering program, it is not called the department, it is not mechanical engineering department, it is mechanical engineering technology department. So they are involved in technology world. It means that this is technology degree. Technology degree, it means that the bachelor, in many cases they are offering bachelors of engineering, which is not more general than the bachelor. The Bachelor of Science, it is more general, qualify you to work on the graduation to acquire any job title related to your major. Make sense? So that's it for today. We just introduced engineering in general. We discussed the different majors. We didn't go deeply through anything. We just discussed what does it mean engineering, what does it mean design, what are the responsibilities, what things that engineering could do. In addition, we discussed the difference between scientist and engineer and the difference between these two degrees. Again, remember that you're gonna graduate with a Bachelor of Science in Mechanical Engineering or a Bachelor of Science in the Industrial Engineering. The next meeting we're gonna discuss the things that mechanical engineers can do. What are the different courses that you are going to study to be a mechanical engineer? The same thing for we're gonna do the same thing for industrial engineering. What does it mean industrial engineering? What are the different subjects that you are going to study as mechanical engineer, industrial engineer? This is gonna be discussed in the next meeting. Make sense? So that's it for this video, and thank you, and see you in the next meeting.